Hey, good morning from Walla Walla, Washington. And I bet you it's going to get hot today, so I'm out here kind of kicking stuff around, you know. So, this machine here, the fabulous Monarch 10EE, is described as a sensitive precision toolmaker's lathe. And it is. And what you have to do with a machine like this is you just don't throw pieces of steel in it. Everything has to be aligned and balanced for the thing to work. That is, if you want it to work like a precision lathe. If you don't, you'd be better off just using a standard lathe. So you just take a little bit more care with this machine. Now, when you get into the higher speeds and stuff like that, then you're going to run into more balance problems with it, with your work and the work holding and stuff. But you can take the techniques that you need to make this machine work and come on over here to the old, I don't know, what would you call this? That Monarch's like a race car. This here's just a big old Mack truck. But you could take some of those little tips and come over here and just get better results. And this three-jaw chuck, my eBay special here, it's actually in quite good shape. And it's an older chuck, probably early 1950s, maybe 40s. And I recognize it because of the pinions are kind of small. The other eight, I got another chuck like this, but it's D13, and it's got large pinions and stuff. And I know this is an older one. These are kind of, you can fudge these and break them. And this one has been used, but not really abused. And it's coming around good. Now, I had to drill this many holes to balance it. Now, these older chucks, they didn't balance them because a lot of lathes wouldn't go faster than 500 RPMs. But I was actually detecting some vibration at, what was that? 473. The chuck would harmonically like go bad at 473 and 849. It ran good, better at 628, and it seemed even better at 1127. But it got a lot of that taper from the imbalance. So just kind of doing some small things like balancing this is helpful. And it knocked a half thousandths off the taper. I was getting in 2.5 inches. But the chuck that rules is the 4-jaw. And I got that on the balance and stand too. And I'll get it back on here. And I balanced it. It had a bit of imbalance to it. And I want to test it again. It's the best chuck. It showed 1/1000th taper using the same tool, depth of cut, blah, blah. 1/1000th taper in 2.5 inches. And this one here was showing up to 2/1000ths. So I go, I got to do something. So I got this one here at 1.5 thousandths, and I want to get the 5C collet chuck back on here because it was like over 1.5 thousandths, and see if I can improve that and talk about 5C collets in my opinion and experience. Okay. I'll be back with something else, I'm sure. Well, okay, down here at the balance stand. This is the last one I'm going to check the balance on, and the balance is not so good. This is a plate that the blade gave me here that it's like it's on its last gasp of being used. It's just full of holes, it's thin, and it's just a little bit out of balance because of all those holes. And instead, I think I got the fix for it. Over here, we'll grab two musket balls. Oh, let me stick one in here. See if I can jam one in there. Oh, look at that. Looks like I think it's going to take two musket balls. I don't know if that one's going to stick, but I'll squish them and get them in there, and maybe a dab of epoxy glue, and I'll have that thing balanced up. I just want to see if this thing's going to work, and I want to talk about 5C collars. Okay, be back. Hey, welcome back here. Now, the reason I chase all this little problems down like taper, trying to hit accuracy and things like that, it's right here. Now, I'm good at sourcing bearings, and this here is a double row angular contact bearing, and I'm going to replace, there's 4 of these, there's actually 6 of these, but I want to replace 4 on the drive shafts on this axle set. So when I get those shafts out, I'm going to very carefully inspect where these mount and what they fit into. And if I'm creating something like a shaft that fits in the bearings like this, I can make a shaft out of pretty hard steel and press gears on it, do all kinds of things. But the lathe has to run good enough to make stuff like this. And if you're doing long shafts, you'll see me extending things out of the chucks. I get the chucks running as true as possible, and I'll extend the work out and center drill it out, right out where it's going to be held. And that way I get all the stress out of the piece of metal, because I'm always making something that potentially goes into that. And I actually got some work from that one guy. Remember those little line bars that didn't line up with bronze bushings because they were not made like that, okay? So that's why I get these chucks run absolutely as true as possible. And that's something you have to do on the Monarch 10EE. But there's also the added problem that I create myself. Now on this axle set, I'm putting together chucks out of used stuff. The blade gave me some old beat up back plates. I bought stuff off eBay. I bought stuff from the famous HGR with their great packaging. A couple of things arrived with the package over here and the chuck sitting over there. So stuff takes a beating, you know. Even the truck that came on this machine, the back was all beat up and I had to fix it, the mounting surface. So I have to fix every single thing on this lathe and everything I've got for it because I bought it at bargain basement prices. But I'll tell you something. Now, the 12-inch 3-jaw chuck, 12.5-inch 3-jaw chuck that came with this machine retails for $3,100, and I think getting it for a good deal, it's about $2,700, and that's almost the entire tooling budget for this machine here that I managed to do on eBay and stuff like that. So keep in mind what I'm doing is I'm making the very best out of very little, including this machine here. It was the least expensive geared head lathe of its type on the entire internet about 2.5 years ago or so. Okay, so that's what I'm up to. And we'll take a look at some results on this 3-jaw chuck. And I want to revisit the 5C collet chuck and give my opinion of 5C collets. You might find it interesting. Okay. Well, I heard you clear in there. What's up? Oh, she just wants some attention. It's going to be very hot today. You're going to keep an eye on her, make sure she doesn't get too hot. And if it's hot where you are, you folks be sure and drink a lot of water. I put ice cubes in her bowl. Okay, all done with this 8-inch 3-jaw chuck. I took and balanced it, and it did improve. I was getting about 2/1000 taper with this, which I thought was excessive. It was more than I was getting out of the 6-jaw chuck, which should be worse than this. So now, let's get that on there. See, I got that bit just about on 0. Let's say about reads about 1/10 over, I suppose. Get it over here. What's it doing? See, it's right there at 1.5 thousandths taper, and that's okay. What I did is I turned this down to 7/8 of an inch, and now I'm going to grab this in that 5C collet chuck. We'll play with that a little bit, and I'll tell you some things about 5C collets that I found out. Okay. This is kind of fun. Let me shut this off. Now I got the 5C Bow Star, genuinely Bow Star collet chuck in there, and I got this 7/8 collet, and it's just really good. The results for taper after I balance this thing, unless I'm reading this gauge wrong. Let's get it on there. And where are we here? I'm going to set it to 0 again here. I hope you're all doing good. Here we are. I think we're stabilizing out there. Get that set on 0. Pretty good. Let's move it over. All the way over. And it's just over 1/1000. Get it back over, get in the middle. It says predictable taper. There's not anything going on with the ways right here. This is all work pushover. So, and things running out of balance. Now that's really good. So now, to improve upon that, I'll just leave this chuck in here, and what I'm going to do to improve upon this pushover is I'm going to reduce the radius on the tool a little bit, start reducing that, and that'll should reduce this pushover even further. And then the next thing you can do is increase the angles on the tool itself. And there's advantages and disadvantages. You can't gain in one area without losing in another. So when you start increasing the tool angles and decreasing the radius, then you start shortening the tool life because you have a weaker tool. And that's why I use this Micro 100, because it's really tough and chip resistance. So you're putting things to the limit here, to the limit of a basic carbide cutter. Okay, I will be back with improvements from here.